Good morning, everyone. This is Mr. Bach, and I want to continue the discussion we've been having about volume. What is volume? How do we calculate it? And where might we use that in a real-world application? Here's a portion of a specification for a 2018 Chevy Equinox. It says it has a 2-liter Ecotec gasoline engine. It also says its displacement is 2 liters and that it has a bore and stroke of identical 86 millimeters. An ad for this vehicle might say that it has a 1.5 or 2-liter engine. What does that mean? And how might we calculate it? Before we do any calculations, we need to understand what displacement means. As a piston moves up and down within a cylinder, it pushes the air or draws the air in. It's said to be displacing that air. That's what we mean by displacement. And its measurement is usually given in cubic inches, cubic centimeters, or liters. The diameter of the cylinder is known as its bore, in this case 86 millimeters, and the distance that piston travels upward or downward is known as its stroke, in this case also 86 millimeters. In these pictures you can see the bore depicted as the diameter of the piston and the stroke showing you how much the piston travels up and down. Of course, when we calculate the volume of one cylinder, we do not have the total displacement of the engine. We would have to multiply that by the total number of cylinders, in this case 4. So, how is that displacement calculated? It's a very simple formula. The volume is pi times the radius of the cylinder times its height. In other words, we're going to calculate a very thin slice of the cylinder, and once we have that area, we will multiply it by the total height of the cylinder, which will give us the total volume of the cylinder. So, to calculate the displacement, we begin with the formula volume equals pi times the radius squared times the height. When we substitute our data, we get pi times 86 divided by 2 squared times 86 millimeters. Remember, we have to use the radius of the cylinder. The bore is given as the diameter. So when we do this calculation, we find that the total displacement of all 4 cylinders is 1,997,215 cubic millimeters. To convert cubic millimeters to cubic centimeters, we would divide by 1,000 and get 1997. And then to convert it to liters, we again divide by 1,000, which gives us nominally 2.0 liters. And that's how we use geometry to answer a real-world question. So let's review. The new Chevy Corvette comes with an optional 6.2-liter V8 engine. What's the total displacement of that engine? That's right, it's 6.2 liters, or 6,200 cc's. How is that measurement calculated? By calculating the volume of one cylinder and multiplying it by the total number 8. So, coming back to our formula again and substituting this time a bore of 104 millimeters and a stroke of 92, we see that the total volume of this 8-cylinder engine is 781,131 times 8, or 6,249,052 cubic millimeters. Dividing by 1,000, we get 6,249 cubic centimeters, or 6.2 liters. And that's how we use geometry to solve a real-world problem. Thank you.